right. This is the first time I've done this headphone thing. Am I good? Everybody hear me? Cool. Okay, so Andre kind of just gave us the rundown of why sBTC. We're going to switch gears a little bit, and I'm going to kind of move into and start talking about some of the how. So the first thing I want to do is set a little bit of context for how we should all be thinking about sBTC, because I think that can help as we kind of go through how it actually works. So the sort of concise way that I like to put it is that sBTC is a trust-minimized solution designed to move Bitcoin between the Bitcoin L1 and the Stacks L2 with as little counterparty risk as possible. If at any point we're taking our Bitcoin and moving it anywhere other than our wallet, we introduce some amount of counterparty risk inevitably, whether that's Lightning, Liquid, whatever we're doing. And so the goal should be, how can we eliminate that counterparty risk as much as possible? And generally, the solution to that is you build an open, permissionless, decentralized system that has economic incentives to try to bring in as many people as possible, decentralize it as much as possible, and that's really the goal with sBTC. So if you're interested in following along, no pressure. I've got 2 links here. The first one's just going to go to the documentation. The second one's going to go to a simple example repo that I have that I'm going to run us through today. But before I jump into the UI and the code, I want to go through just a little bit of how sBTC actually works. And so the basic process is, if I want to do something with my Bitcoin, enter it in some form of a smart contract, whether it's decentralized borrowing, lending, options, whatever that might be, what I'm going to do if I want to use sBTC is I'm going to take my Bitcoin, I'm going to use a wallet, I'm going to send that Bitcoin to a threshold signature wallet, and this can basically be thought of as a decentralized permissionless multi-sig with multiple different people that are all taking part and collectively signing these transactions. So my Bitcoin's going to be sent from me to that threshold signature wallet. When that happens, the sBTC system is going to detect that transaction, and it's then going to trigger sBTC to mint on the stack side, and that's going to send that sBTC to me into my wallet. It's a SIP10 token that gets generated. We'll go through this in a little bit more detail as we go, so if this isn't quite making sense yet, don't worry. We're going to walk through this step by step. So then I can take that and I can do whatever I want with it with any sort of Clarity smart contract that somebody can build. I've got this sBTC, which is a SIP10 token. If you're not familiar with Clarity and SIP10s, you can think of this as similar to a custom fungible token on Ethereum, similar concept. So I can take that sBTC, do whatever I want with it, and then when I'm done, what I'm going to do is take my Bitcoin wallet again, and again on the Bitcoin side, I'm going to initiate what's called a withdrawal request, and what that's going to do is that's going to, again, create a Bitcoin transaction that gets posted to the chain with certain data embedded in that transaction, which will then trigger the sBTC system to basically request a withdrawal. And what that's going to do is tell all of these signers collectively, hey, somebody's requesting a withdrawal. What that's going to do is check, okay, do they actually have the sBTC required to process this? If they do, then the signers will collectively sign that. It requires 70+% of the signers to agree to that. Then it's going to burn the sBTC on the stack side and then send the Bitcoin from the threshold wallet back to the original user. So that's the process in a nutshell, and that is kind of what we're going to go through today. As Andre talked about, we're on the developer release right now, which just got released. And so what this basically allows you to do is it allows developers to experiment with a localized test version of sBTC. So what we're going to be actually looking at today is that I have a local mocknet version of the sBTC system running on my computer right now. So if you go to the documentation link that I had up there before, you'll see a few different things, but one of the things you'll see is a local development environment setup. What this basically is it recreates the process of this signing scheme that we just talked about, recreates it as a single binary that can run on your system so that as a developer, you can experiment with what the developer experience for building on sBTC is actually going to be like, build UIs, so that way when the official release comes out, very simple to just port it right over to the original release. There's going to be some changes and adjustments on the way, but that's the goal behind the developer release. So what I want to do now is go through a very basic application that I've built called Lagoon. And this is basically a super simple borrowing and lending application that's designed to work with Bitcoin. So it's going to have 2 main components. There's going to be a bridge functionality, which is where we're going to take our Bitcoin and we're going to convert it to sBTC. That's what we're going to go over today. And then the secondary functionality would be this lend and borrow over here. And these are hooked up to Clarity smart contracts. We're not going to go over those today because we're focused on sBTC. But the link that I gave right here, that second one, that's going to take you to the sample repo so you can look at and go through and explore all this for yourself. But if we go through this process, this is going to be denoted in Satoshis. So right now what I'm about to do is I'm going to open the Leather wallet, which is one of the products that Andre talked about, but it's a wallet that works with Bitcoin and stacks very cohesively and seamlessly. I'm saying I want to take 5,000 Satoshis worth of Bitcoin, and I want to convert it into sBTC. So I hit deposit, and what this is going to do is this is going to call up the Lether wallet, and this is generating a Bitcoin transaction. Now, one of the difficult things about Bitcoin development is that for any advanced functionality, you have to custom build these transactions from scratch, and that can be extremely difficult. So one of the pieces of the developer release that Andre talked about is this SDK, and what that's going to allow you to do is just with simple JavaScript functions, it's going to allow you to pass a couple pieces of data, and it's going to build that custom transaction for you. So I'll go through the code in a second, but what this is doing is this is saying that I'm going to initiate a new Bitcoin deposit. So I'm transferring this amount of money, and then I'm going to be losing this amount of money. So this is the threshold signature wallet that I was talking about. I'm about to send Bitcoin to that wallet, and I'm going to encode some data in there that has my stacks address, and that's what's going to tell the protocol, okay, read this data contained in the op return field on the Bitcoin transaction, get the stacks address out of it, and that's going to call that mint function, send it over to that stacks address. So if I hit confirm here, that's going to give me a transaction ID, and I can go over here to the mempool explorer, pop that in here. So this is a local Bitcoin node that I have running, and here's that Bitcoin transaction right there. So next what we can do is we'll go over here to the Stacks Explorer, and now we can see this mint function's been called. And so what happened is I initiated that Bitcoin transaction that's a deposit transaction, encoded my stacks address in there. The sBTC mocknet binary that I have running on my system detected that transaction. You can see that right here. So you can see this create mint right here. And so this is detecting that transaction. It's reading the op return data and saying, okay, I'm going to mint this sBTC to this stacks address. If we go back to our Lether wallet and look down here at assets, we can see that I've got some sBTC right here. So all of this sBTC has been minted as a result of me depositing my Bitcoin into that threshold signature wallet. There's a UI bug in the wallet right now that's because it thinks I have 0 Bitcoin. I don't, but that's why that says 0 right there. These are actually connected in the same wallet interface. So this is the Bitcoin address and account that I use to initiate that deposit transaction. So now I have sBTC as a SIP10 token, which means that I can do anything that I want with it and anything that I can do in a Clarity smart contract. So let's look at the code a little bit. We'll look at the front end first, and we'll look at the smart contract code that actually handles this. So this is just a basic React form, but the bulk of the work is happening in this build transaction function right here. So when I hit that deposit button, that called this build transaction function. And this is going to be leveraging pretty heavily this sBTC package that we have right here. Eventually, this will be part of stacks.js, which is Hero's like Stacks developer tool JavaScript ecosystem. Right now, it's just a standalone package, so you can install it with npm install sBTC. But this is going to give you a ton of different helper functions to make it easier to, one, interact with the APIs in the way that we need to, but then two, to also construct those transactions in the format that we need to. So what we can tell it right here is that we're working on the developer environment. So it's got this dev-env helper, and this is going to set some configuration variables that are going to make sure that when we're calling APIs and things, it's not trying to call testnet or mainnet. It's going to call our localized one that we have running in the background. And all this stuff is also covered in detail in that quick start tutorial that I gave at the beginning. We've got the local environment set up. I've got an end-to-end tutorial covering everything we're about to go here. So you can go back and look at that whenever you want, go at your own pace, and see how all this is working in detail. But then what we're doing here is we're getting our Bitcoin address, and then we're fetching our UTXOs. So this is one of the difficult things about working with Bitcoin as a developer is the UTXO system is different than how the account system works on Ethereum. So what you have to do with Bitcoin is you have to go through and find all of your UTXOs, and you basically have to pick one or multiple of those to use as inputs. And so that's actually a little bit of a pain to do, and so this package lets you do it in just one line, and that's going to pull all your UTXOs and decide which ones should be used as inputs for this deposit transaction. And I have some stuff commented out here because a few of these functionalities will work a little bit differently depending on if you're on testnet or devnet, and we're on devnet right now, so I have the testnet section commented out. Testnet is not deployed yet. We're still working through some stuff there, so devnet is what we're working with here. And then what we're doing right here is we're getting this peg account address. So this is where we're actually going to be sending the Bitcoin. In the deployed version of sBTC, once it's done, what we can actually do is we can call the sBTC deployed contract directly, and the peg address is one of the contract fields there, so we can just directly call the deployed Clarity Smart contract to get that address. And this is where the bulk of the work is happening, is in this sBTC deposit helper function. So we're passing in a few different parameters here. The default network is DevNet, so we don't need to pass that here, but I have it uncommented if we wanted to use testnet. Then we're passing in that peg address. We are currently connected to this UI with our wallet. You can see the disconnect button right here. And so we have access to the Stacks address that we are connected with right here. Then we're going to send it the amount of Satoshis we want to convert. That's what we entered in that field. We also have a built-in helper function here to estimate the fee rate that we need to set in order to get our transaction actually processed. We're passing in the collection of UTXOs that we just got. And then finally, we're passing in our own Bitcoin address to get our change. If you're not familiar with how change works in Bitcoin, basically what it means is that UTXOs can only be processed in whole increments. So if I have a UTXO with 50 Bitcoin, but I'm only sending 5, I'm going to send the entire 50 and then send another UTXO back to myself with 45 as the remainder. So that handles this here. And then the Leather wallet requires these to be formatted as a partially spent Bitcoin transaction. So we're converting that here. And then we're just passing in our public key and then the raw hex of the transaction that we just built. And then right here, this is what actually calls that window that we just looked at to confirm that transaction and actually broadcast it to the network. So that's the deposit flow. So then what actually happens after that point is that will get sent, that will get processed excuse me, by the sBTC system, and that's going to then call a mint function in this Clarity Smart contract. So this is the sBTC smart contract. This is what actually handles the transactions on the sBTC side of things. So when somebody initiates a deposit, this mint function gets called. And this is just a basic SIP10 token. So we can take any workflow that you have with SIP10 tokens in Clarity, you can just move over to sBTC and do anything that you could do with any other custom SIP10 token. But the key part that happens right here, and why Stacks and Clarity specifically are uniquely suited for a system like sBTC, is that what we're doing right here in this line, we verify transaction ID exists on burn chain. We're actually calling a function down here. And this contract call is calling a Clarity Bitcoin helper library. It's calling the wasTransactionMined function. And what this is actually doing is that this is using a built-in function in Clarity called getBurnBlockInfo. And we're passing in a couple different pieces of data there. But what this is going to do is this is going to allow us on-chain to actually check the data that's being passed into a Bitcoin block and make sure that it's legitimate. So what this allows us to do is on-chain with Clarity, verify that this transaction that's being initiated to mint this sBTC actually happened and has actually been mined on the blockchain. So we do that in a couple different steps. The first thing we do is we use the Clarity's built-in function, that getBurnBlockInfo function. That's how we're going to pull in the header information for that transaction. So that gets, because of the way that Stacks is connected to Bitcoin, that's happening on-chain. We're reading directly from the Bitcoin chain, directly on the Stacks chain with this Clarity function, getting the header information, pulling that down, and then what we can do is we can pass in the transaction ID, and we can use what's called a Merkle proof to verify that the transaction itself is legitimate. So we verified that the transaction in the block exists on-chain, so now we need to compare that to the transaction that we've passed here, and we can do that with the Merkle proof. I'm not going to go into details about how those work, but at a high level, basically what happens is you take every transaction in a block, you hash them together 2 by 2, and you keep doing that up a tree until you have a single hash left at the top. And that's a way that we can verify that all of these transactions are legitimate. So this is actually, once somebody initiates a mint transaction, the system is not just trusting that they actually have this Bitcoin and that they actually sent it. Before it mints that sBTC, it will go in and check, did you actually send this Bitcoin to the correct address? Has the transaction been mined? And then it will mint it. So then I do what I'm going to do with my sBTC, and now I'm ready to bring it back into Bitcoin. What I'm going to do here is a withdrawal transaction. And this one actually happens in 2 steps. So the first thing that I'm going to do is I'm going to sign this withdrawal transaction. And this is actually, I'm signing a message on the Stack side right now with this same Leather wallet. So what I'm doing here is I'm passing in a message in a specific format that the sBTC protocol is expecting. basically saying that I am the owner of this Stacks address, and I am going to be converting this amount of sBTC to Bitcoin. And the reason I'm signing it is because then that's proof that I actually am the owner of the Stacks address that's trying to burn this sBTC. So now I have that signed message saved into my state right here. The button switches to broadcast. I'm going to take that message, and now I'm going to broadcast this withdrawal transaction. So this is a very similar process to how the deposit works, except it also contains this signed Stacks message basically saying this is what I want to do, because ultimately what we have to do with the sBTC system is we're initiating Bitcoin transactions that are encoded with instructions for what the sBTC system should be doing. So in this case, we signed this one to prove that we're the owner of the Stacks account. We hit confirm. This is going to give us another transaction that we can verify here in our Explorer. There's the transaction. We'll wait just a second for this to be confirmed. And then after that, the next thing that's going to happen is we are going to get a corresponding burn function right here. And so what this is doing is basically the same thing in reverse. At this point, the sBTC system is detecting, okay, I just saw another withdrawal request. I'm going to verify that that person actually owns this sBTC, and then I'm going to take that same amount of sBTC, I'm going to burn it, and then I'm going to call this threshold signature wallet and say, okay, time to process this withdrawal transaction. And then those signers will collectively sign that, and it will get sent over to the person that requested the withdrawal in the first place. So that is the sort of whirlwind tour through the developer release. Again, I have a quick start tutorial that will kind of take you through all of this step by step. But this is, like, everybody in this room is very literally some of the first people to work with sBTC, and so this is kind of the first foray into that. The goal with this Lagoon application is to gradually build this out and turn it into a fully fledged, full-featured DeFi app with Bitcoin so that people can take it, use it as an example app to build off of things like that. So with that said, I'm going to hand it over to Christopher, who's going to start going into a little bit more information about what kind of things we can be building with sBTC, give you a little bit of inspiration for, and I'll let you know why we're doing it, how to build it. Now we're going to talk a little bit about, okay, what do I actually build?